Okay, we are going to start chapter 6.4, but this is 6.6, and it doesn't make sense where it's at in the chapter because you kind of need it for chapter 4 or section 4. But you might have learned this in Algebra 1. You might not have. So let's talk about this. If you have 25 to the 1/2, that is actually saying 25 to the first, which is 25, and then 2 is your index. These mean the same thing. You don't really write 2 because it's so common, so your answer is actually 5. Okay, so this is called a rational exponent because it's a rational number. So this is in your notes, and it just kind of goes along with section 4. Section 6, I'm not going to go into detail because this is it. We'll just touch upon a few of these. So if you have 125 to the 1/3, that's saying 125 to the first, and then the cube root of 125. Well, that's like saying 5 times 5 times 5. I need a group of 3, bring it out. So when you have cube roots, you need a group of 3. When you have 4th roots, that means you need 4 numbers. So it's saying 8 times 8, or 2 times 2 times 2 times 2 times 2 times 2. So you need a group of 4. That's the answer. It's not pretty, then that's fine. Okay, so we're touching upon that. So this is section 4. So we said this is the index, this is the radical, and then this is called the radicand. So x to the 3rd is 64. That means 64, which is 4 times 4 times 4. 4th would be the cube root. So the cube root of 64 is 4. So if I have a to the n is b, that means it's a times a times a, n times, we don't know how many n times is, equals b. Therefore, a is the nth root of b, or the nth root of b is a. So in mathematics, these are examples. You can't prove something with examples. You need variables. The higher math you get, the better you'll get with this. It's more professional. Okay, here, they're asking what the square root of 16 is. It's 4. What's the square root of y to the 4th? Well, essentially, this is like 2. So you could write 4 4s and then take the square root, or you could just say y to the 4th divided by 2. And that's kind of why you needed to know 6 6, which is y squared. They had a plus minus in front, so you just put a plus minus. It really doesn't mean anything. You don't really do anything with it. They're just saying, are you intelligent enough to realize it transfers? Yes, you are. All right, this quantity is to the 8th power. But since it's a square root, we could just do, which is just this. All right, here, what is the 5th root of 243? What is the 5th root? What's the 5th root? That's all they're asking. Okay. Here, oh, we have a negative. We can't take a negative as a square root, so the negative has to stay inside. So what's the square root of 16? 4. That negative stays inside. What's the square root of x to the 4th? You could write 4 x's and take out a pair and take out a pair, or you could have divided by 2. So you could have taken 8 and divided by 2 and gotten 4, and this is the square root of -1. So if you wanted to put I, sure, you could do that. All right. They say you try. Well, the square root of 36 is 6. Half of 10 is 5. Same thing here. Half of 16 is 8. I don't need you to FOIL all that. That's fine. And it's negative just because there was a negative here. Okay. Next page. Okay, they're doing the same thing. But I'm going to talk about something else here. Your answer here is y, or it's the absolute value of y. Now, what you would have naturally done is said, okay, I have 4 y's, so I have to take one group of 4 out, and I'm left with y. But here's the thing. If y was a negative number, let's just say -2, and I put -2 in, -2 to the 4th is 16. What's the 16th root, or the 4th root of 16? A +2. So if I put a negative in, a positive is still going to come out. So that's why you can write the absolute value. I don't care which one you do. And here's the thing. A lot of times you don't even use this unless the directions specifically ask. So I wouldn't worry about it. Here, let's try it again. 8 times 8. So we need a group of 6. 18 divided by 6 is 3. Here, 2 is never going to be negative, so I don't need absolute value bars around the 2, but I would need them here. You do not have to do this, but you can. Here, we'll get 6, y to the 3rd. Here, we will get 2, 2, 2, 2, so it's 2. Here. Absolute value bars just go around the odd because, yeah, if it's an even root with an odd power, you'll only get a positive. You do not have to put these if you do not want to. All right, now here's a word problem. It says, if c equals the 5th root of b squared, and that represents collisions and bicycle riders per intersection, estimate the number of collisions if there are 1,000 bike riders a week. So you could just put this right in your calculator. And I don't have my graphing calculator on me, but then you just type that in and you will get your amount. And here they're saying this isn't anything like earth-shattering. They're just saying, okay, now let's just solve with equations with radicals in them. Now here they're saying they're giving you the amount of collisions. How many bike riders would there have had to have been? Well, to get rid of this 5, you take this to the 5th power. And then to get rid of this 2, you take the square root of that. Whatever that is, that means that it had to be about how many bicycle riders. So they're just saying, hey, let's just work on word problems. Don't be intimidated by words. It's just explaining a lot of times the equation. And I think this is 6-5. So I think that's it for, yeah, that's it for 6-4. Now 6-5 is actually easier. A lot of it's just breaking down. I'll make a separate video for that one next.